Hi, I'm Dr. Courtney with the Quantitative Reasoning Center. Cadets at the Air Force Academy and college students everywhere are often concerned with how they can make more efficient and effective use of their time. So when you're studying or watching these videos or attending a class, you will remember the content 3 times as well if you take good notes. So simply that act of taking good notes renders the use of time three times more effective. Alright, we're having a look at section 12.3, problem number 43, which asks, if the vector A, and it's given, find a vector B so that, and we need to interpret this properly. This is the scalar projection of B onto A is equal to 2. So a lot of cadets get to this problem and they haven't worked very much with the scalar projection of one vector onto another, and they just kind of throw up their hands and say, I don't know what to do. But let's go ahead and use our idea problem solving format, where I means to interpret or to identify the big idea that's necessary to solve the problem. So for I, we want to use the scalar projection to find the vector B. And let's interpret this a little more, because what does it really mean to find the vector B? Well, these are 3-dimensional vectors, so to find the vector B means we're finding the x component, the y component, and the z component of the vector B. Alright, now to develop, we want to make our plan. That's what the D in idea stands for, is develop. And sometimes you draw a picture. This problem's a little more abstract, doesn't really require a picture so much, but we do want to make a plan. So for our plan, so what do you say we look up the formula that tells us how to compute the scalar projection of B onto A? So we want to find the formula for, because this is the thing that's equal to 2, right? And let's express in terms of components. And now let's set this equal to 2, and then we solve. And rather than just saying solve for the vector B, let's be a little more intentional and explicit about saying that we're solving for the x component, the y component, and the z component. And let's also note that it just said to find a vector B. So there may be more than one right answer to the problem. Alright, so flipping back a couple of pages to the formula. This is equal to the vector A dotted with the vector B over the magnitude of vector A. Now to express this in terms of components, what would we do? Well, let's go ahead and substitute in our A, our 3, 0, negative 1, and then B is our unknown vector, over the magnitude of A. So let's just have a little aside where we compute the magnitude of A, because it's simply going to be the square root of the x component squared plus the y component squared plus the z component squared. So this is 9 and that's 1. So A, the magnitude of A is the square root of 10. So all this business here is equal to 2. So we've expressed in terms of the components, and we've set it equal to 2. So now we can evaluate the dot product. So we have 3 times the x component plus 0 times the y component minus 1 times the z component. Let's go ahead and multiply both sides by the square root of 10 is 2 times the square root of 10. And what does this immediately tell us? Well, one of the things that this immediately tells us is it doesn't matter what the y component of b is. Because when you take the dot product with the vector a, you multiply it by 0. So the y component of our vector b can be anything. Well, what about our other two components? Well, our other two components need to be chosen so that 3 times the x component minus the z component is equal to 2 times the square root of 10. In other words, this is an under-constrained system. And we only need to find one vector b. So why don't we use one of our things that we know and just make one of the components 0 so the other component is really easy to find. So just set this one, actually probably a little easier to set the x component equal to 0, and then the z component is simply negative 2 times the square root of 10, so that our final answer is we set the x component equal to 0, the y component could be anything, might as well make it 0, and the z component is negative 2 square root of 10. Alright, so interpret, develop, this was the evaluate step of the idea problem solving format. And how would we assess? How would we take a step back and double check our answer to see if it's right? Well, in this case, we can simply, we know the vector A, we know what we found our vector B. If we take our B that we found, plug it back into the formula, and we get 2, then we've assessed, we've done a pretty good double check on our answer, and then we'd be sure that we were right. Alright, so now we want to 3, 0, negative 1, dotted with 0, 0, negative 2, square root of 10, over the square root of 10. So the denominator is still going to be the square root of 10. 3 times 0 is 0. Plus 0 times 0 is 0. Negative times the negative is a positive. So these two terms are 0. The square root of 10 cancels out.